I'm going to have a look at how we can make a quiz in Python starting from scratch and try to explain a few of the steps and the processes that you might go through if you're doing something similar yourself. The first thing to do is have a clear vision of what your quiz could or might look like. It doesn't matter if you change that vision as you go along, but it does help to have some sense of what you want in the end. So I'm interested in some kind of quiz that gets me better at guessing the size of the population of different countries, or perhaps the relative populations. Do I know whether there's more people in India or in China, etc., etc. So I've gone to REPL or replit.com, and you can sign up for free on here, and you're able to start running code without installing anything on your machine. I'm going to make my code in Python. It's called Country Quiz. And the first thing I'm going to need is some data. So to get my data, I had a quick hunt for world country population, and Worldometer was the most easily accessible on here. I've got a table of data that looks like the kind of thing I want. It's got information about population and also the land area and so on. So I've got a few things I can play with should I want. Now, you can do some more sophisticated web scraping than this. What I'm doing is probably not technically web scraping. I'm copying and pasting the data. The easiest way to do this is probably to start by opening up a text document and pasting the data directly into there. Yes, it looks horrible, but the next thing I do is copy and paste once more. And I'm going to put it from here into an Excel spreadsheet. The advantage of going into a text document first is that we don't have to worry about any awkward formatting issues. You can see that once it goes into Excel, it recognizes, for instance, whatever the delimiter was here, maybe tabs have been used to separate between different columns. You can see, if we move our columns a bit, you can see that basically most of the information in the right sort of structure is in here. Some of it looks a little bit odd. For instance, we can't see the headings there anymore, but there's a useful trick you can do there. If we copy and then paste special transpose, changes rows to columns, columns to rows. And again, that may not be perfect, but it's probably going to be roughly comparable to these things. We can double check to see if it actually fits with what we're expecting here. So for instance, the kilometers squared, if this is likely to be the area of the land, maybe we need to shift these along a bit. So it's not the most sophisticated approach, but it does the job. And we can double check that the numbers match the headings we're interested in. And of course, the main thing we're interested in here is the population. So this is the country in this column, this is the population in this column. And if we were interested, the land area looks like this one, the density looks like this one. And we can double check that if you divide the population by the land area, we get a number that matches what we had there for density. So these values here we don't necessarily need, even if we're interested in the population density. We're more interested in the population itself and potentially the land area for the country. The other thing to notice is that Excel has already automatically recognized that these are numbers. So it's numerical data that it's reading in. And even if it looks like there are commas in there, if we were to do something like equals this and is the population, we can see that the data under the hood for Excel is just a number. We can change the format up here into general and then the commas disappear. This is helpful because what I want to do in order to pull this data into REPL is actually something a little backwards perhaps. We're going to take it from here. I'm going to put a comma followed by the population number. China, comma, and then the population. Now, if I put this next to the column, then to fill down, I don't have to drag all the way down. I can just double tap on this button on the bottom right, and the formula is copied all the way down to the bottom. Hold down Control and press the arrow keys to jump to the end of a row or a column. And you can see that we've got here an entire list that basically matches country, comma, population. If you want to make sure there are no additional commas, you can check by doing something like is error find comma in here. So if there's an error finding a comma, it means there isn't a comma. If we put not in there, it'll be the equivalent of saying there is no error finding a comma. And so false is what we want. If it shows up with a true, then that will be an indication that somehow there's a comma in the data that we're trying to deal with, which potentially will cause an issue because then we'll have multiple commas in the output data that we're trying to generate. Another nice thing to do with this, in Excel, we can use 1 times. If we multiply something by 1, if the something we're dealing with is perhaps text that could be a number, like 223, if we enter it with an apostrophe, this is useful if you're doing a phone number, then it's recorded as text for Excel. But if you then multiply it by 1, it's recognized as a number which you can then do stuff with. So it wouldn't make sense to try to add 1 if something wasn't a number, but Excel recognizes that if you're trying to add 1 or if you're trying to multiply by 1, then what you're dealing with must be some kind of numerical data. So it kind of changes the data type depending on what you need. So you can copy down this and it'll flag up if there are any issues, and we can just add that column. If we find any ones, we know we've got a problem, and we can hunt for them either for ourselves or we can use match, see if we can find a 1 anywhere in this column. Exact match basically means it's going to look for a 1 and it'll tell us where that 1 occurs, in this case position 3. If you want to know the name of the country, then you can use this column and ask it to look in position 3. So we can see the United States in position 3 is where the error comes from. You can also use conditional formatting to make it show up more easily. So when you zoom out, you can see where the errors might be creeping in. You can go there, you can fix it. And of course, if there were multiple errors, although this will show up the first one for you, once you fix the first one, it'll then show you the next time a mistake has occurred. We can go and find that one and fix that one as well. Now there are no more errors, so we don't need to worry. In this particular case, the data set was fairly clean, so it wasn't such an issue. I'm now going to copy this column. I'm going to go back to a text document and just paste it in. In fact, what I'm going to do is take that entire thing and put it directly in my REPL as a file. So I'm going to make the new file. I'll call it data.txt. It's not a code file. It's not something that will be run as code. It's just a text file. But what we're going to do is read it. And we read it using this clever method with open data.txt, comma, r as in file. What this does is takes away any of the issues that can occur with opening a file, doing stuff to it, and perhaps forgetting to close it afterwards. So imagine if you shut down a computer without properly saving a file, potentially the data is lost, potentially it gets corrupted because it's not been properly saved back to disk. If we do all of our working with the file within a with block, then it's automatically opened at the beginning and closed at the end. The other thing that's going on in here, I give it the name of the file to look for, and provided it's saved in the same folder as the program, so if you're doing this on your own machine, save it in the same place that you've saved the program file, the py file, it will find it automatically. If not, you might need to add information about which folder it's in. R stands for read. The most common alternatives will be W for write, but bear in mind that will overwrite a file if it exists. If it doesn't exist, this will create a new file and write in it. Or A for append, where you want to go into the file and add stuff at the bottom of the file as an additional line. We just want to read it. We don't want to mess with the values within the file. But once we've opened the file, the simplest way to pull out all the information is to use this, infile.readLines. It will read all of the lines and turn it into an object. We can see what kind of object we get by printing the lines afterwards. So if we run this code now, you can see this looks like a bit of a mess, but it starts with square brackets. So we know we're dealing with a list, and each element in the list is a text string that looks like China, comma, 14393237776 \n. That \n is an important thing. In fact, we'll see what it means if I say for line in lines, print line. So now I'm iterating through that list and printing each individual item in it. So it's going to print this for me, and then it's going to go to the next line and print the next one. But if you look at what happens when we run this, because this is now full up, you might need to clear what's on the screen so you can see what happens next. There's a gap between each line and the next, and we've lost that \n. That's because \n is actually the new line symbol. If you were to print something like hi \n Bob, then what you end up with is hi and Bob on separate lines. It's effectively the character you get if you press the enter key on your keyboard. And that's useful, and that means we can go from one line to the next, but it's something that we need to deal with if we want to pull out this number separately to the name. So the first thing to notice with this line is that I'm interested in not the whole thing, but what I get if I strip away any white space characters. This will basically get rid of any spaces, any tabs, any new line characters from the end of your text string. So it will produce for me a sort of a tidier version of this thing. If I ask it to print this, for instance, what we should see is the same data but without the gaps. So that's what we were hoping for. But we don't necessarily want to print it. What we want to do is extract the two separate pieces of information that are in there. And the way we do that is by splitting. Split with a comma essentially takes this text string and says, actually, this is two different things, and here's how you know that it's different things. Every time you see a comma, that's an indication that you want a new thing. So comment that out for a second and give you an illustration. If I print this, obviously it's going to come out as all one single string, but if I put split and then I decide to use space as my delimiter, then what should happen is that I get a list with separate words. Every single word is now a separate item in the list. And of course I could use anything to make the split. I could use the letter I if I wanted to. It's going to come out looking a little bit weird because every time it sees I, that's an indication to the program that it needs to break the string at that point. If I use a comma, then everything before the comma is the first bit and everything after the comma is the next bit. So that's what we're looking for. What we should have now is a convenient way of pulling out both the country and the population. So we could even write things like using the F string and a replacement field. This will give me the country name as a population of, and then another replacement field for the population. This should print for me a slightly more user-friendly version of the information. Marshall Islands has a population of 59,190. All well and good. But what if I wanted to pretend the population was twice the size? Now, this is a little strange. You might remember that Holy See has a population of 801, if you've been paying attention to the bottom of the screen. But now it appears to have doubled it into 801,801. Same thing has happened with some of these others. And if we look more closely, you'll see that this is a common theme. It's doubled it in the same way that it would double a text string. Remember that if you were to print hi times 5, what we would get is hi, 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 hi. In other words, Python can multiply text strings by 5, but it will do it differently to the way you might expect it to multiply numbers by 5. We know 6 times 5 is 30. Python believes that 6 times 5 in this context is 66666 because it treats it as a text string, which means that what we need to do before starting to work with the population is convert it into an integer. Python can do that. It can happily turn something that appears to be a text string into an integer, provided it's something that can be turned into an integer. And if we do that, we'll find that we can do normal numerical things with our population. So now what we should find is that it's still lying about the population, but now at least it's doubling 801 in the more traditional sense. That's going to be useful for us if we want to do any comparisons between the population of one country and another. But in fact, we don't necessarily just want to print all this information out. What we want to do with it is put it in a convenient place in the program so we can refer to it and work with it. And probably the most effective way of doing that is using a dictionary object. I'm going to give it an unimaginative name of data because it's the only data I'll be working with here. And I don't need to worry about having duplicated the word data because this is only going to be referred to when I pull data out of the text file. So data is going to start out as an empty dictionary, but then each time I go through this list of data and extract the country and the population and turn the population into an integer, then I need to put this information into my data dictionary. So I use square brackets, country is going to be the key in the dictionary, and then the value will be the population. Now at the end, we can print data and see what that dictionary will look like. It's going to be messy, but now we can see, if you look carefully, that each item starts with this curly bracket, so we know it's a dictionary. Each item has a key, which is a text string, in this case, text string representing the name of the country, and then the value is a numerical value. It's an integer representing the population. And also, because the data we inputted initially was in order of population, we also have this added benefit that the data is already ordered for us. If it wasn't, the easiest way to do that would be probably in Python. You could go to data and sort. If you click sort, you get to choose things based on what you want to organize by. If you want it smallest to largest, it can change it around for you, and so on. That's also possible to do in Python. For now, we'll leave it like this. Now, what I want to do with this data, not just print it all out, to be sure. What I'd like to do is make this into some sort of quiz. I want to see how good I am at guessing which country is the biggest. To do that, it's going to be helpful to have a way of picking out random countries. And you might think that we can make use of the random modules method for choosing things at random. For instance, I can use random.choice to pick something from a particular list. If I make a list of colors, blue, green, red, then when I print random.choice, I'll get either blue, green, or red with equal probability. So each time it happens, it'll produce one of those things with probability 1 out of 3. However, if I try random.choice data, it doesn't like it. It says it can't do this because when it tries to apply that, whatever's going on behind the scenes in the random module, it doesn't like, because it's trying to treat data as if it's a list. And we don't have a list. We've got a dictionary, which is inherently an unordered data structure. It's not a list. If we want a list, then we can generate one from the dictionary. Country names will be the keys, data.keys. And if we print country names, you'll see that what we get looks a lot like just a list of country names. But look carefully at the beginning, it says dict_keys. In other words, this is not just a list. In fact, it's what's called a generator. It's something that can produce something that behaves like a list, like a range object. It's more efficient than a list for certain things, but it is not yet a list. To force it to become a list, I have to tell it that I'd like it to be a list. Once I've done that, it becomes something that the random module can work with, and it can select for me, for instance, there we go, a random country from the list of countries which was produced from the data dictionary. So here's our random country, and here's another random country, here's another random country. So we've got a way of choosing a country at random. Now, the next thing we want to do is perhaps choose more than one country. Luckily, we've got another useful function from random. Random.sample will allow you to select a sample of, for instance, in this case, 2 different countries. So it'll pick out for me a couple of countries. The other nice thing this does is avoids the issue of if I just selected a country at random, then another country at random, potentially they'd be the same country. So this will give me 2 different countries from that list. Not only that, but once I've got those, I can unpack them. I can say there's 2 things there, country 1 and country 2. Once I've got those countries, I can say something like country 1 has population, and then I can look it up in my data dictionary. Data dictionaries you look up for using keys rather than indices. So you don't put an index in there, you put in the name of the key. And when we set this up, we designed it so that the key would be the country and the value would be the population. C2 has population, data C2. Even if you don't think this is going to appear in your final program, printing these little bits as you go along is a good way to pick up the errors before they mess up the entire program. There we go. Isle of Man has this population, Turkmenistan has this population. Brilliant. It seems to be working the way it should. Now, if we're going to turn this into a quiz, we're going to want to do something like ask the user which of these 2 has the greatest population. So let's try that. To get input from the user, we use input. And we can also use f strings within an input. So which has the larger population? The options are C1 or C2. Now this is fraught with potential issues because the user might have to type in Turkmenistan, and if they don't type it in exactly right, then it's going to be hard for the program to know what they meant. So a lazy way around that would just be to allow the user to type in either 1 or 2. And that way, when we interpret their guess, we assign that to a value so we can do something with it. We get a 1 or a 2 stored in memory and we can work with that. Now we can decide whether they were correct or not. So what should happen now is it'll ask me which of these 2 is larger, Bangladesh or American Samoa, and I can make a choice and press enter. And at the moment, all it does is tell me the 2 populations. What I can do is use my guess and figure out if I was right or not. The simplest way to do that is to pull out the population data directly at the point when we first come up with the country names. So the population of country 1, the population of country 2 will be the data that corresponds to country 1, data that corresponds to country 2. The values in the data dictionary that correspond to the keys C1 and C2. Now at this point, we already know what the correct answer is, because we will know which of C1 or C2 is the larger country, because it depends on whether P1 or P2 is greater. So we could say something like, if P1 is greater than P2, the correct answer would be country 1, which would be a value of 1. Otherwise, the correct answer would be 2. Once the person's made their guess, we can say if guess equals correct, then we'll say well done. That'll do for now. Otherwise, that's not right. So let's see if this works. Mali or Denmark? Let's guess Denmark. That's not correct. Mali has a population of 20 million and Denmark is only about 5.8 million. Now it's a little hard to read off those numbers, so you might decide you want to do some rounding or turn things into the nearest million. Another simple approach is actually to make use of that new line character. So instead of putting the 2 bits of information on the same line, we can just put in \n in the middle of our text string, and it will print it as a new line. Let's see what this looks like. Tolokau or Solomon Islands, they're both pretty small, but let's go Solomon Islands. No, wrong again. Toggle out is 1,357. Okay, in this case, it looks like the program is telling me I'm wrong, but actually I was right. 686,000 is bigger than 1,000 and something. So what's gone wrong here? In this case, the two countries were Tokelau and Solomon Islands. We got the population of each of those, and we said if the population of the first one is bigger than the population of the second one, then correct is 1, and if not, correct is 2. Now, the population of the first one shouldn't have been bigger than the population of the second one, because it's 1,000 and some instead of 686,000, which means we should have had correct equals 2. And then I guessed 2, but it wasn't indicated as correct. The reason for that is that when we get the guess from the user, notice that the guess is not recorded as an integer. It's recorded as a string. It's going to tell me I'm wrong every time, even if I'm correct, because 2 in Python's head is the string with the character 2 as opposed to the number. One simple way to fix this is to force Python to turn that into an integer. Now if we try it, Togo or Malaysia will guess Malaysia, and we're correct. And we can see from this that the populations are sufficiently different. We can see that Malaysia's got a much bigger population. If you want to see how much bigger, quite a useful extra bit, you might include the ratio of the two sizes. So the ratio will be something like the size of the larger country divided by the size of the smaller country. And the easiest way to do this without checking and changing around is just to say the maximum of the two populations divided by the minimum of the two populations. That will automatically divide the larger by the smaller. And then perhaps to keep things easier, I'm going to round it to one decimal place. Because I don't care about the precise ratio, I just want to know roughly how much bigger one thing is than the other one. And then we could say something like that's a ratio of 1 to ratio. Let's see what this looks like. Azerbaijan or Monaco, I'm guessing Azerbaijan. I'm correct. The thing that I've done wrong here is this needs to be a \n. Ratio of 1 to 258.4. My goodness. Slovakia. Yay! 1 to 24.9. So I shouldn't feel too chuffed because Slovakia is 25 times bigger. So it's not that impressive to know the difference. Now, if you want to change up the difficulty of this, one simple way is to remember that we've been looking at the population of all of the different countries listed here, which is quite a lot of them, 235 different countries. And remember, our list was in order of population size. So the larger populations were at the beginning, with all the countries that you're more likely to have heard of, and then the smaller populations towards the end, with a bunch of tiny places that you might not even recognize the names of. If you want to make this a little bit easier, then a simple way around would be to only select from a smaller collection of country names. So let's build in something called level. This would be like the player's level of competence. Let's start them off at level 0. And well, level 1 might be more sensible if we're going to be indicating this to the user. It makes more sense to start at level 1 at the beginning. And if you're on level 1, then you'll only be tested on country names within the first, let's say, 10 countries, which means I can use slicing here to give a subset of all of the country names. It's got a complete list of country names, but they're in order of size of country. This is one of the nice things about the way dictionaries work in Python 3 since one of the more recent updates. Although it is an inherently unordered data set, the keys and the values will be automatically in the order in which they're put in initially. So this country names list should be in order, and we can double check that by doing something like print country names from the start. That's the default if we don't put anything here, all the way to, say, the 5th item. So 0, 1, 2, 3, and 4 should be printed. That's the first thing that will come out. It doesn't like it because I've started but not finished it. There we go. China, India, United States, Indonesia, Pakistan. They were the 5 largest countries. So they are already in order, and we could use that slice idea here to go 10 times level. So you get tested on the first 10 items if you're on level 1, and you get tested on the first 20 if you're on level 2, and so on. Perhaps we could make this a bit different. If you wanted to go up in bigger jumps, you can mess with that yourself later. So at the beginning, we're on level 1, and if we test this out, we're making some fairly simple calls like Brazil or the United States, and it's all good. Obviously, at the moment, this is a fairly boring game because it asks you a single question and then you're done. But we can use this idea of a ratio to determine how difficult the question is. If 2 countries are very similar in population, it's going to be harder to guess which is the best. So you perhaps deserve more credit if you're correct, and you stand to lose less points if you're wrong. So you can build that in. Once you know the ratio, you can decide how you want the ratio to affect the number of points you get awarded. If you want to keep track of your points, start with 0 points, and we can build that into the game. Now, if we look here, we can find we start the game with this level and this many points. We get the data from the file. We go through the lines of data, we sort it all out, we produce our data dictionary and our country names, and then the stuff that happens next is something that's going to have to happen again every time you run the code. You want to ask the question to decide whether you're right and to give the information. So I'm going to make this a while true loop, and everything that happens after this will happen within that while true loop. So highlight it and press tab, and you'll indent the whole thing. It will select from the country names based on what level. It will decide what you'll need to determine in order to be correct. You make your guess. If your guess is correct, it says well done. Otherwise, it says not right. One little thing that might go wrong, if the user enters something other than the numbers 1 or 0, you can account for that using a try except loop. So with this, you can attempt to get a guess, and if it doesn't work, then you can either do nothing at all, in which case the thing won't crash if you get it wrong. Which has the larger population, Indonesia or Pakistan? If you type a word instead of a number, it doesn't like guess. It's trying to decide if guess is correct. So we either would have to decide what guess should be here, or we need to give the user the opportunity to try again. One way to do this is to build in another while true loop, which we will only break out of when the user finally manages to successfully type a number between 1 and 2. If they can't manage that infinitely, they deserve to be stuck in an infinite loop. So we try to get a guess, and if we can't get a guess, we'll give the user some input. We'll print something like, sorry, didn't understand that. Enter 1 or 2. And as soon as it's printed that, it's going to loop back and try again. Once it tries again, if it manages successfully to get a guess, then we're going to say if the guess is either 1 or 2. So if it's in this list of valid inputs, then we're going to break. That means we break out of this while true loop, and then the game can continue, because now we've got a guess, we can compare it to correct, which is either 1 or 2, and everything will carry on as it should. Let's try that out. Nigeria or Russia? I'm going to guess Russia, and I'm wrong. It was a 1 to 1.4, so I don't feel too bad. It's now asking me again, what's the larger population, Nigeria or Russia? And I'm wondering if it's because it has not refreshed this, or if it's just randomly chosen the same 2. It's not impossible for it to choose the same 2 twice in a row. It's choosing from just 10 countries after all, but it seems a bit unlikely. This time, I know the answer. Maybe it was just fluke. So I got it right that time. And this time I'm going to try breaking it. China. Sorry, didn't understand that. Enter 1 or a 2. And it asks the same question again because it didn't understand my answer the first time round. And if I get it wrong again, it's going to ask me again. And if I continually get it wrong, it keeps asking until I eventually make a guess. And if I made the wrong guess, then it's going to tell me I'm wrong. And then it moves on to a new question. The next thing you'd want to do here is probably build in how you get points and how many points you get. So one nice way to do this is to use the ratio itself. The larger the size of the ratio, the easier it should be to guess. And therefore, you would want to earn a small number of points if you guess correctly, or lose a large number of points if you guess incorrectly. So the size of the ratio basically tells you how much you should stand to lose if you are wrong. So let's say that if you're correct, the number of points you have goes down by the ratio. If you are, that's if you're correct, it goes up by something. If you're correct, you gain a number of points which is the reciprocal of the ratio. So if it's very close to 1, then you're likely to get something like 1 point. But if it's way off, like one of the countries is 20 times the size of the other one, then you're only going to be awarded a modest number of points, like 0.05. On the other hand, you're going to lose points according to the ratio itself. You're going to lose 20 points if one country is 20 times the size of the other. If that feels a bit unfair, then we can modify this slightly. So one way to do it would be to square root the ratio. We think about how this works. If you've got ratios between 0 and 1 and you square root our ratio is always going to be bigger than 1. If you square a number between 0 and 1, it gets smaller, but if you square a number that's bigger than 1, then it's going to get bigger. If, on the other hand, you square root your number, then it's going to get smaller. So although within the 0 to 1 range it gets smaller, beyond the 0 to 1 range, square rooting will reduce the size. So you can go up to 9 and the output will still only be 3. So this is going to limit how many points you lose if you lose. And the simple way to do a square root is a power over half. Now with this one, 1 over the ratio, the biggest that can ever be is 1, because I've designed the ratio to always be the ratio of the larger to the smaller. So 1 over the ratio may be getting close to 1, but it could also be much lower, because if you're doing 1 over 10, it's down to a tenth, and so on. If I want to make that a larger number, so I'm earning a few more points, or I'm earning closer to 1 point, I can do the same kind of thing I did there. I can take the square root. So you might think this is a fairly punishing way of doing the points. If so, feel free to change things up a little. Make it so you get twice as many as that when you earn points. Make it so you get half as many as that when you lose points. Try it, see what feels right to you. And then perhaps in addition to giving you points, you could tell the user. So you could say something like, current points, and then they know how many points they're on at the moment. Current level. This brings us to the next bit. If they get a certain number of points, it makes sense to level up. Let's bring this points information, we give them a little lower. So that happens after we tell them about the countries. We can say if points is greater than 5, level plus equals 1. Although now we're thinking you're at a higher level and your points is already going to be greater than 5, you're just going to increase your level over and over and over again, which is not going to make much sense. So we need to have something where the level is determined continually based on the number of points. Maybe we say that the current level is equal to points double divide by 5. In other words, if you've got fewer than 5 points, it's going to come out as a 0. Maybe we'll make it 1 plus, so the lowest it can ever be is 1. As soon as you get 5 points, then integer division by 5 will give you an answer of 1. 5 points, or 6, or 7, or 8, or 9, or 9.7, something like that. When you do integer division by 5, you'll end up with an answer of 1, which puts your current level on a 2. The reason I put current level instead of just updating the level is so I can say if current level is greater than level, in other words, I want the level to change, then level equals current level, and you can print something like level up. You're now on level. So we don't need to tell them their current level every time over here, but we can tell them if they level up. And remember, once you level up, you get tested on a greater number of country names. This potentially will get as high as the entire list of countries. So although Python may not have a problem with a value that's bigger than the end of the list, it might be most sensible to make sure this never goes beyond that. So the minimum 10 times the level or the length of the country names list. Seems like a sensible thing to include. In other words, if 10 times the level gives you an answer that's bigger than the number of things in the country names list, we're going to max out at the total number of things in the country names list. Let's try it out. Bangladesh or Russia? Let's go with Russia. The ratio is 1.1. I appear to have lost some points because I was wrong. Didn't lose too many, minus 0.5. It's an awkward number to lose, so let's tweak how we do the points here. This is going to give us hopefully a relatively sensible formula, but it'll be useful to round it, perhaps. Round it to 1 decimal place. And we could do the same thing with this one. In fact, what might work even better is if we just give an integer value, then we're not going to get floating point errors. And if I wanted 1 decimal place of accuracy, now I'm going to multiply by 10 and make it into an integer, so things should be fine. Obviously, we can make that a bit simpler. And we can, of course, tweak these numbers if we decide we want to change things. So it's going to be an integer, which is related to that formula that we've got. Hopefully that'll add or subtract a sensible number of points, but that might mean that 5 points is easier to come by, so we up this to something a bit bigger. We'll see how that works. Indonesia or Bangladesh? I'm going to go Bangladesh. I was wrong. I've lost 6 points. Indonesia or China? That one's China. I've now gained some points because I'm up to 2 points. It might be nice to know how many points you get when you're correct. So when we say well done, perhaps if we do that just after we work out the number of points, we can have this complicated bit here being the number of points you earn. We earned that many points. Don't forget, this now needs to be an F string. Alternatively, this is how many points we earn, the negative of that. And we'll need to tell the user not only that they were wrong, but also how many points they lost. Confusing with these negatives. So let's say instead of earned, lost. You've lost that many points. And then here we will lose a positive number of points. Let me try it out again. Brazil or Mexico? Let's go Brazil. We earned 15 points. It was a 1 to 1.6 ratio, so we get 15 points. India or Indonesia? It's going to be India. Now we're up to 8 more points because we didn't get as many points that time because the ratio was a bigger ratio. So we were expected to know this one more easily. Vietnam or Russia? Russia's quite a bit bigger than Vietnam. We got 16 points for that because actually it's only about 50% bigger, apparently, population-wise. Which has the larger population, Turkey or Japan? Let's go Japan. 16 points. And now I've leveled up. There we go. It took a few questions, but I got them all right so far. So now I'm up to level 3, apparently. I must have jumped far enough. It looks like we can level up pretty quickly. You might want to adjust that. Make it a little harder to level up, because if you can get 20 points in one go, then you might skip across a level. Now, if you wanted to try different things, you could incorporate additional data. Remember, our original data set had other information as well. We had density, land area. You could ask questions about which one is the most high density country. So places like Bangladesh, or even some with a very small population, the Vatican City, for instance, Gibraltar, Monaco, ludicrous level of population density. So that would change things up. If you can incorporate some additional values, all it takes is changing your formula a bit so that you include things like land area. You can include the density in here straight away, or you can calculate it on the fly if you need. Remember, we just copy that data into a text document. We can put it directly into here if we want to. The difference will be we've got 3 pieces of information in there. So when we extract it, it's not just country and population. It's country, population. The next one was land area, and then we had density. So let's go area, density. And for population, area, and density, we would need to change them all into integer values. So to make my life easier, I'm going to keep these as single letter variables just for now. Population, area, density all need to become integers. I'm going to do simultaneous assignments, so I keep it all on one line. And then the data is going to be a list of population, area, and density. And then we go through carefully to make sure that what we're doing works here. We've got a question about population. Data types, or perhaps fields, would be a good thing to have here, so that we know what we're asking about. Population, land area in square kilometers, and the other one will be population density, people per square kilometer. The reason I'm including that is so that we can modify our question. We might decide randomly at the beginning not only which countries to choose, but also which type of data we're going to look for. So field would be a random, let's say random.choice fields. Or perhaps better would be a field index, which is just a random integer between 1 and the length of fields. This will make it easier to adapt subsequently if we want to. And then the field we're interested in is just fields with that index. The reason it's helpful to have the index is that I can use it then later on when I'm picking out which of the bits of data I want. So I've got here, what I've currently got here is P1 and P2, which would have been population, but in reality because the data C1 is now a list of 3 things, I need to pick out the appropriate thing. And that will be determined by the field index. So data bracket C1 will give me a list of 3 things. Data bracket C1 field index will index that to give me the thing that I want. And then when I get to here, instead of saying which has the larger population, I'm going to say which has the larger, and then use the replacement field for field, which has the larger population, or which has the larger land area, square kilometers, which has the larger population density. And the rest, although I have got P here, everything else should work. We just need to make sure we replace any mention of population with the name of the field that we're working with, and most other things should do what they're supposed to do. Now it's going to test me on more things, so it will be more challenging. Let's find out where we've got a problem. Field index is not defined. Field index, fields index. I need field without an S. Which has the larger land area, China or Russia? Possibly Russia. China has land area. Oh, interesting. When it gives me the data, it needs to use the field index. Otherwise, it gives me all of the data. So this is the same sort of thing we did when we first pulled out P1 and P2. And data C2, field index as well. Let's try this again. Doing funny things. Let's refresh it. Which has the larger land area, Russia or India? Let's say Russia. I earned 8 points and then everything crashed. List index out of range. Field index should be an integer between 1 and 3. So 3 things in that list. If we're not sure what's going on, oh, I know what's going on. It's giving me a number between 1 and 3, but of course I need to index with it, which should be a number between 0 and 2. Rand int works differently to the way a range value would, so I need to subtract by 1 in here. That's why it's been asking about land area, but it hasn't asked me about population. It was choosing between land area, population density, and a third thing that doesn't exist. So, which has doing some funny things. Which has the larger population? Go with China. We've got 9 points. Which has the large land area? Say India. That was 22.8 times the size, so we didn't get very many points for that one. 4 points. Larger land area will go Russia. And then larger population. Ooh, it was not Brazil. But it was a 1 to 1.3 ratio, so I don't feel too bad. I only lost 5 points. What has the larger population density? Brazil or India? Let's say India. We got 4 points. And population density was massively bigger in India. So we only got 4 points for that one. Seems to be working. And if we ever end up with more points than 40, I believe, then we will level up. So there we go. That's our program.